Okay. So on the homework, if they don't say solve theta within a certain interval, then you're going to find an infinite number of solutions. So this part A, let's say solve for theta between 0 to 2 pi. So all you have to do is look it up on the circle or use your calculator. Let me use a calculator so I can show you this technique. So the idea is you do cosine inverse of both sides. So theta is equal to cosine inverse of 1/2. I'm going to do it in degrees. So doing this earlier. Cosine of 0.5 is 60 degrees. Now, theta 1 is equal to 60 degrees. The second theta is going to be 360 minus 60 degrees, which is 300. So let me write you a rule here. If theta is in quadrant 1, let's write that better. Theta 1. Then theta 2 is in theta 2. So I'm trying to make up my own rule here. Give me a second. Theta 2 will equal 360 minus theta 1. Okay. We'll double check in a second. Actually, let's double check now before I mess it up here. That's weird. Strange. Oh, that's fine. So we said that cosine inverse is 60 degrees, right? This guy? This cosine is 1/2 at 60. So the calculator is going to give us that answer, but it cannot give us the other answer because we can see the other ones right here, correct? So visually, you can just take them off, write them down. So to find this one, you just do 360 minus the one you found. That's the rule if cosine is in quadrant 1. Does that make sense? So when you're solving this, if you get a theta in quadrant 2, then theta 2 is equal to 180 minus theta 1. So cosine is a little annoying. It has two separate rules. Now, of course, if you're not using your calculator and the answers are on the circle, just write them down. Who cares? They're on there. But eventually, you're going to get at questions where it's not a nice number. It could be like cosine equals to 0.37 So that's when you use this idea. Does that make sense? Any questions on what we did? This is the calculator. Gave us the first one. Second one is found by subtracting from 360.
Why do we use the inverse of cosine?
I did it just so I can show you these two ideas here. It wasn't necessary, right? So inverse cosine cancels this to solve for theta. When you're solving this, you're solving for theta. Okay? I put it in degrees just because it's prettier. If you don't use degrees, you're going to get a decimal unless you have a very fancy calculator. Any other questions on part A? Okay, so if they do not give you this restriction, let's say all they do is say solve, then you're going to find all the solutions, okay? But since we already did it up here, then all you have to do is tack on the infinite piece. $360K. So every time I go around 360, either where K is an integer, I'm going to get an infinite representation. I can just keep going over and over again, either negative or positive. So this set creates an infinite set, and so does the other one. So if you want all solutions, if it is not restricted, just add this piece where K is an integer. So K is a whole number, positive, negative, which also includes 0. Okay? Does that make sense? Because you can keep going around and around forever, right? So this restriction up here forces you to just go around once. So if they don't restrict it, then you have an infinite set for every angle you find. Any questions on part B?
So how do you know it's like, will you always give like a restriction? Like,
Yeah, they'll tell you like solve for theta within this range.
Okay.
And if they don't tell you, then assume infinite infinite solutions. So assume this scenario. They have to tell you something. But, right. Do another one. You guys cool on this page? Just remember, if they say nothing, then assume this. I don't think I can jam one in here. So sine theta equal to 1/2. And they're going to tell you straight up from 0 to 2 pi. So 1 period. Now, if we pretend that wasn't on the circle, which it is, you would have to do the inverse sine, right? That will solve for theta. Inverse sine of this guy, I don't know what that is. I think 30 degrees, right? So sine inverse gives me 30 degrees. So the rule, theta 1 is 30 degrees. So the rule for sine is different. So these two rules right here, make a note. This is for cosine. For sine, it's a little more chill. And all you got to do is every single time subtract from 180. You'll be good. So this right here is a rule for sine theta. Okay. So if you're doing inverse sine, it's all you have to do. Cosine is the one that's annoying. It depends where it lands. Any questions on 1 and 2? So just remember that cosine inverse is defined in the top half of the circle. So depending where it lands, you have to adjust. Okay. Sine is the right half of the circle. So really all you have to do is this. But if you end up with a negative angle, just adjust by adding 360. That's all you have to do. And I'll wait a bit.
Is it possible for it to make
Only sine will give you a negative. So that's when you have to adjust by adding 360. Because sine inverse is the right half. So it has to be between negative pi over 2 to pi over 2. So I mean, technically there's a second rule, but I don't think it's worth mentioning. Just make it positive like you did before. And test 1. All right. We're gonna do a bunch of examples today. This is the last section for test 2. I think test 2 will be on Monday. You have a week notice. I will let you know if I adjust it. No, we don't. That's awesome. I guess Wednesday. What's Monday? Oh, so it's perfect. So we'll review Wednesday and maybe Friday, and then I'll see you Wednesday. Okay. So here, notice they didn't tell us about theta. They didn't say anything. So assume all solutions. Okay. Now, the idea is isolate the trig function. So get the trig function by itself. Once it's isolated, use the inverse or your unit circle. Okay. If you have to factor, go ahead and factor. If you need an identity, use an identity. So all that will be in play. So +3. That'll give us -2, right? Divide by 2. We have solve for sine. So at this point, you can just look it up on your circle. Sine is -1 at which angle? Yeah, 270 or 3 pi over 2, right? There's no other one, is there? That's gonna be it for this one. So just add the infinite part. 2 pi k instead of 360k. Oh, sorry. Should be z. If you want to use English, you can. The math symbols is k is an element of z, which is the integers. Z represents a set of integers. Lowercase epsilon means element of. If you want to just say what we did over here, you can say it this way if you want. I don't care. Doesn't matter.
That's the part of our answer.
What's up?
It has to be part of our answer.
Yeah, it should be. Otherwise, I don't know what k is, right? If k is a real number, then it would be wrong.
And we put that because they didn't give us free.
Yeah, we got to tack this on because without a range, then that means I can cycle through forever, which gives me an infinite set of solutions. Any questions on number 3? So basically, you just solve for your trig function and do what we did in the first 2 examples. Okay. You may have to do all kinds of algebra steps. Just depends. Now, check this one out. I'm going to go ahead and use the circle this time. I'm not going to use a calculator for a bit just because we don't have to. At least not yet. So here they told us theta is restricted, right? Okay. So solve for your sine. Add the 1 over. Divide by 2. And then you get to here. What do you think we got to do? How do we deal with the square? Yeah, we're going to square both sides. But when you do, what happens to the number? We always have to tack on that extra piece. You remember? Every single time we put the plus or minus. So now that we have a plus or a minus, you're going to have twice the number of solutions, right? Should be four angles. So this right here will become sine equal to plus or minus square root of 1 is 1, root 2. If you rationalize, you will see this is very familiar, right? Square root of 2 over 2. You've seen that before on the circle, right? All right. Why don't you let me share that damn thing? So weird. I guess it's letting me show everything. Okay. So square root 2 over 2 for sine will be here, and negative there, negative here. So all 4, right? So the 2 positives and the 2 negatives. So our answer will be the big theta set. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. These all from the circle. Okay. You could use your calculator, but you would only get 2 of them. Then you'd have to subtract to find the other 2. Okay. When you're using your calculator, yeah. Whenever you square root something, you have to put the plus or minus, because because technically when you're squaring something, it could be both. Because if you square a -1 and a 1, you get the same thing. So we're compensating for that part. So either or is possible. So we solve for both. It's kind of like we're saying, right, this line right here says sine theta equals this, or sine theta equals this. So this is equal to both. Anyway, any other questions? Does this make sense?
You wouldn't add the rare case.
No, because they told us one period, so we don't have to. So always check, did they mention a restriction or did they not? And if you do use your calculator, I would recommend using degrees. It's a lot easier to deal with. Okay.
How would you create degrees?
Hit mode and then go to degrees. See it? Just toggle and press enter on degrees. You guys cool on this page? You find it?
Yes.
All right, let's do, this one's kind of weird. We're on 5. Solve cosecant of theta equal to -2, where theta is between 0 and 4 pi. So that means it's not infinite, but it went around twice, right? So we should have an extra set, not an infinite set, but assuming this has 2 solutions, I should find 2 more if I go around. Okay. So whenever you have an extra period, you're gonna double whatever number of answers you find. So just add 2 pi to your answers is what you're gonna do. What is cosecant as a ratio? Yeah, this is 1 over sine, right? If I flip them over, take the reciprocal of both sides, we know how to solve this, right? You've done this before. We did it, I think it was just a bit ago. So theta 1, where is sine equal to -half? Seven pi over 6. Where's the other one? 11 pi over 6. Okay. So all we have to do is add 2 pi, and you'll get the second set. Plus 2 pi plus 2 pi. Does that make sense? So these first two are from 0 to 2 pi. These are from 2 pi to 4 pi. So we add one more revolution to compensate for this 4. So if it was a 6 pi, you would do it one more time. Okay. So 7 pi plus, that's a LCD of 6, right? 11 pi plus 12 pi. 7 plus 12. 11 plus 12. All right. So here are my 4 solutions. Is there any questions on what we just did? Is that okay? There are no proofs in this section, so you're just solving. Back to back to basics, right? Solve sine theta equal to 0.8. So 0.8 is not on the circle, right? So you have to do calculator. So you got to do sine inverse of both sides. So theta will be this, whatever this is. $53.13. It's around a 1 decimal point. So since we're doing sine, the rule says the first one is given to you by the calculator. The second one is found by subtracting from 180. Yeah. So here you have no choice but to use calculator. Okay. Any questions on number 6? Is it okay? Okay. Let's do a cosine that's similar. You guys cool on this page? All right. So they did not give us a restriction, so we'll have to tack on the 2K pi or 360 pi. 60K. What is seeking as a reciprocal? Yeah, so we 1 over cosine. So we'll do the same thing we did earlier. Take the reciprocal of both sides and then use your inverse cosine. Inverse cosine of both sides will give us our theta. Negative 1/4 is not on the circle. I got to do it with the calculator. $104. Let's round to 1 decimal. 104.5. So theta 1 is 104.5 plus 360K. What quadrant is 104? Where do we land in? So if we're in 2, the rule said subtract from 180, right? And that's it. So theta 2 will be 75.5 plus that infinite piece. Theta 1 will be whatever the calculator gives you, plus the 360K. Okay. Any questions on number 7?
You might explain that K.
Yeah, K, this is telling us that K is an element of the integers, which means K can range from any integer. So 0, 1, 2, or -1, -2, -3. So all those are options. And as I choose them, I create infinite solutions. So this lets us choose. If K is 0, then I get the straight up that answer, right?
Right.
If K is 1, then I get one revolution. K is 2, I get another one. It just keeps going. That's all that's telling us.
K is that K is
Yeah, I can say that. K is an integer, or is any integer. That'll be better. Okay. Any other questions on 7? Do a few more. I know this is a lot of them, but there's many different types because of algebra. I don't think I have enough space. You guys cool on this page? Just let me know. Let me know if I'm going too fast or whatever. All right, so here notice it's a quadratic type, right? So obviously we're going to have to factor. What you can do is say, you know what, let x equal cosine. So you can see easier. This is just x squared plus 3x minus 1 equal to 0. So just solve this guy and change it back to cosine later. If that makes more sense in your head, you can. If you want to go straight up, you can, I guess. But does that factor? Does it factor easily? It looks like we're going to have to do quadratic formula, right? Life sucks. Just how it is. Quadratic formula says you can use it for this type of form. So in our case, we have -3 plus or minus the square root of 3 squared minus 4 times 1 times negative 1. Everything divided by 2 times 1. So it's not going to be pretty, I guess. 3 squared minus 3 squared plus 4. Yeah. Negative 4 times 1 times negative 1 would be positive. This is 9 plus 4. Okay. All right. Well, that means that x is equal to negative 3 plus or minus square root of 13. Well, actually, let's do it separate. We have two solutions, the plus and the minus. Right? So we solve for x, but x is made up. We're not looking for x. This should be cosine and cosine. Does this make sense to you? We solve for cosine, not the x. X was made up. So once you get to here, we're back to like the previous question when you have to use the inverse. But I'm out of space. But let's see. So cosine inverse of this thing (73). Now do the same thing but with a minus, and I get an error. So that means that this has no solution. This guy. Because this is outside the range of the inverse. It's too negative. It has to be between -1 to 1. This is less than -1. It's like negative 3 point something. I don't know. If you want to know what number that is, plug it in, but it is below -1. So I can't use it. So I'm going to use only this one. And when we solved it, we found θ1 to be 72.4 degrees, which is in which quadrant? Yeah, it's going to be 1. So that means 2 will be here, right? The rule says if it's in quadrant 1, just subtract from 360. You'll get the second one. So that will be 287.6 degrees. Whatever. Any questions on this one? Yeah, well, we would have 4 if this wasn't, if this had a solution. So only this one produced solutions, this one did not. So we got 2 from this one. We got 0 from here. We could have potentially had at most 4, but it didn't happen. At least not on this one. I'm not going to give you anything like this on the test because it's obviously too long, but you'll see this type of stuff on your homework, okay? I'll pick something more simple for example, something that factors pretty, like x plus 2, x minus 1 or something. Okay, let's do just a couple more and we'll call it a day. You guys cool on number 8? Okay. You guys okay on this page? All right, just let me know. This one right here, how would you solve it? Two sine squared plus sine equal to 0. And if you see a square, you should be thinking factoring, right? How do we factor this? Right, just they both have sine in common. So factor sine. It's not crazy. Once it's factored, you can set each part to 0. And you're pretty much good. Solve for sine by subtracting the 1, then divide by 2. So solve this one and solve this one. So using your unit circle, where is sine 0? Yeah, it'll be quadrant 1 at 0, right? Okay. Where is sine equal to negative half? Which angle?
So
Yeah, what's up?
factor sine theta. So like just cancel the last step.
Yeah, just pretend you had like something like this. You just pull out the x, right? That,
Choose the right.
so it's the same thing. It's the same thing, you see? Is the factoring part bothering you? Or which part?
Yeah, like
Yeah.
yeah, like when 2 sine theta plus 1 equals 0. Why do you do less than?
Oh, like why were they separate here? Oh, whenever you have something factored and equal to 0, you can always set each factor to 0. Like when we had, like if this was you remember when we would factor like this, right? You would set each part to 0. It's the same thing. It just has a sign in it. Same things you've done before. All right, so sine is equal to negative half. Where is it? There it is. 11 pi over 6. And yeah, 7 pi over 6. That makes sense. Okay, let's do one last example and we'll call it. You guys have any questions on number 9? Yeah.
How do you know when to use the acidic?
You can use it whenever you want. But you have to use it when it's not on the circle. Like if you have a weird decimal, like this is on the circle, so it's fine. You don't have to. But you could if you wanted to. But if it was sine equal to like 0.73, you have no choice. You have to use calculators. You guys cool on number 9? All right, last one. Promise. Doing a lot today. I picked the weirdest one from the book. Here you go. Because you guys have been doing double angles and all kinds of stuff. So here we have to use it. And there's not just one way to solve this. You could do maybe like sum to products, something like that, right? Because you have cosine, cosine, sine, sine. You could do change it to a sum or difference of angles. You can also just change these into your double angle formulas. So it doesn't matter how you approach it, just isolate it and then get to a point where you can factor. And if you can, set it to 0. So let's see. Earlier I chose to use the double angle on this guy. Remember in the notes I said there's 3 forms for cosine double angle. One of them was this one. This is the cosine 2x plus sine. Sine double angle was 2 sine cosine. And put an arrow because it's already equal to something, so too many equals looks weird. Distribute the cosine on every single one, distribute the sine. Well, this is not a distribution, it's just a product, but this is a distribution. Cosine times cosine squared. Cosine times sine squared. Sine times that would just be 2 sine squared. All right, you guys with me up to this point? That make sense? That weird? Okay.
So which voltage?
Or so I use the double angle for sine to do this guy. There's only one form. And then use a double angle for cosine 2x, which has 3 different forms. I use the first form. So cosine squared minus sine squared is equal to cosine 2x. Sine 2x is equal to 2 sine cosine. Okay, that's just part of the double angle formulas. That's all it is. At this point, I'm gonna, I don't know, factor, I guess. They all have cosine in common, right? Maybe that'll help. I don't know. I'm gonna try something. Yeah, it looks like it's gonna work out. Excuse me. Factor the cosine from the first term, cosine from this one, cosine from that guy. So now I have 2 minus 1. So that will become cosine squared x plus sine squared. What is cosine squared plus sine squared? Yeah, it's going to be 1, right? So at the end of the day, we're going to have cosine equal to this, which is something that you should know how to solve now, I hope.
Two sine squared x.
Oh, so 2 minus 1 is just 1. They combine these two. Once you get to here, you use the Pythagorean, which is a 1, so it's gone. So you're left with just that cosine. That makes sense? Which step? Here? Here to here? Yeah, so they all had a cosine in common. So I factored a cosine from the first term, became a square. This cosine is gone. That cosine is gone. So I pulled cosine from all 3 terms. Then combine these two to get this. This plus this is a 1. So I'm left with 1 times cosine, which is cosine. That makes sense? Sorry? Oh, this is the double angle. So use sine double angle and cosine double angle to get to there. So just use the formulas. After that, we're just doing algebra and some factoring, and then another identity. So I'll make you a note right here. First step, use double angle. But again, this is not the only way you could do this. You could do it many different ways. This is what I chose. Okay. Anyway, x is equal to, on your circle, pi over 6 plus 2 pi k. X is equal to 11 pi 6 plus 2 pi k. All right. Just give me a second. I'll put this back on.